In this video, we're going to look at the graph of secant x and cosecant x and their variation. Okay, so remember that secant is one of our cosines, so secant of x is also an even function, such as secant of negative x is equal to secant of x. So if we look at our cosine of x, we get this orange curve. And so since it's 1 over, at the high point of cosine, we're going to get the low point of a secant. At the low point of cosine, we get a high point of a secant. I want to point out what are these vertical lines about. Well, those are the places the cosine is 0, and 1 over 0 is infinity. So we get these asymptotes at pi over 2, negative pi over 2, negative 3 pi over 2, positive 3 pi over 2. And as we get, notice as we get closer to 0, 1 over those values gets more and more, gets larger and larger and larger. Or on the other side of that, from the other side, where it's below the x-axis, going more and more negative. Likewise, with a cosecant function, it's just 1 over sine. Cosecant is an odd function, so cosecant of negative x is negative cosecant of x. So again, these high points for the sine are the low points for the cosecant, and then the low points for sine are the high points for the cosecant. So very much like the graph of the secant, but just shifted. Here, sine is a function that is 0 at 0, pi, 2 pi, negative 2 pi. So that creates asymptotes for the cosecant function. So some breakdown of this. Y equals a secant of bx minus c plus d. The stretching factor is absolute value of a. Our period is, we're back to 2 pi period, 2 pi over absolute value of b. Our domain, because we have these vertical asymptotes, are everywhere except c over b for shifting plus pi over 2 times absolute value of b times k, where k is an odd integer. Our range goes from negative infinity up to negative absolute value of a, then to absolute value of a to infinity. Because you see there's this boundary in the middle that it's not going to meet up. So we have a gap in the range of a secant and a cosecant function. There's no amplitude. Y equals a secant bx is an even function because cosine is an even function. Then we look at the details for this cosecant. Looks very similar. The amplitude, the period. Here the domain, though, is going to be c over b plus pi over 2b k, where k is an odd integer. Same thing for the range, and our vertical asymptotes are going to be at c over b plus pi over absolute value of b, k. I feel like these need to line up. I feel like that 2 shouldn't be there, because it's the asymptotes where this is going to be, so I'm going to go with that. And then there is no amplitude, and this is an odd function because sine is an odd function. Okay, fixed it. So graph one period of 2.5 secant of 0.4x. So one period, let's go ahead and get what our period would be. That period would have been so it's going to be 2 pi over 0.4. So what is 2 pi divided by 0.4? I get 5 pi. Okay. And maybe we'll just change the down below the our values. Okay, so let's see. I'm going to go from negative 1.5 pi And this would be pi here. We'll call that pi. And this would be, I'm just going to call it 3 pi over 2. And we have half pi, pi, 3 halves pi, 2 pi. Then we have 2.5 pi, 3 pi, 3.5 pi, and 4 pi. Now, if it's 5 pi, this is a secant, so that's going to be an even function. So it's going to be kind of straddling the y-axis. It's not horizontally shifted. So at 2.5 pi, think about this for a second. Okay, so at I'm going to back up and go with this. I know that secant of x is going to be undefined whenever x is going to be pi over 2, 3 pi over 2, and negative pi over 2. So I want to go back and figure out where those would be in this setting. So now we're looking at 0.4x is going to be pi over 2. So if I divide by 0.4, x would be what? That would be at 1.25. And same thing if I said 0.4x equals negative pi over 2 divided by 0.4 pi, I should say. X equals negative 1.25 pi. And if I looked at 3 pi over 2, so 0.4x equals 3 pi over 2, x would be 3 pi over 2 divided by 0.4, and that would be 3.75 pi. 75. Okay, so I think we have some information that we can work with here. So if this is 1.5 and this is negative 1 here, so right in between there, we're going to have a vertical asymptote. And then over here, if this is 1, that's 1.5. We have a vertical asymptote here. And then 3.75. So that's 3, the 3.5, that's 4. So 4 between 4 and 3.5. You'd have a vertical asymptote. Okay, I think that's starting to come together. Now, the amplitude is important because normally, I mean, that's going to tell us how far down it's going to come. So 2.5 times 1 is 2.5. So right about, that's 3, sorry. .5 will come right across here and right across here. So let's think about this. Cosine is going to be positive in this area, so the secant is going to be positive coming down like that. And then this is going to come up like that. Now we'll look at graphing. Oh man, this got messed up. Let's do that. There we go. Y equals 4 secant of pi over 3 minus pi over 2 plus 1. So let's look at our period. So period, oh, the pen died. Period would be 2 pi over pi over 3, which would be 6. So we're going to have a period of 6. we have a shifting, a phase shift. That's going to be pi over 2 divided by pi over 3, which becomes 3 halves, which is 1.5. So with a period of 6, it would have gone from, boy, it's tough to kind of visualize this, well, like negative pi over 2, but now that we're shifted, and coming up with a new period, this is why I made this graph the way it is. The period will go from 0 to 6. And let me just try to express why. So we would have vertical asymptote here. Why there? Because if I put 0 in for x, then we're looking at secant of negative pi over 2, which is undefined. So then I know that that's a vertical asymptote. I know that 6 later is another vertical asymptote. Boy, if I could draw a straight line, it'd be helpful today. Now, something else to think about, if I put 6 into this equation, pi over 3 times 6 is 2 pi. So 2 pi and then minus pi over 2 puts us at 3 pi over 2, which is not defined there. And then we know that midway at the 3, so pi over 3 times 3 is pi minus pi over 2 is pi over 2, secant's not defined there. So that's going to give us our asymptotes. Okay, what else do we have? We have a shifting going on. We did that horizontal shift, and then we have this plus 1 is going to give us a vertical shift of 1. So our center line, instead of being at 0, is going to be at 1. And then the 4 out front tells us that's only going to go down. If they were at the center line of 0, it'd go down to 4, but now it's shifted up by 1, so it goes down to 5. And then it'd be 4 from the other direction, so that's going to put us at negative 3. So if I were to graph this, it's going to come down, go down to that, and come back up. And then this will come up from below to that and go back down. And that would be roughly our graph. I guess I could extend these down here. Extend this down like that. Okay, the next one is a cosecant. So our cosecant doesn't have a vertical shift or horizontal shift. We're just going to see this as a change of a period. So our and this negative 3 on front, it's going to change it. So instead of being something like this then that, the negative 3 is going to make it into a this then that. So the low part first. Okay, so our absolute value of A is 3. Our B is 4, so our period is going to be 2 pi over 4 or pi over 2. Well, that's a small period. And I wasn't really sure what to do about scaling this one when I made the graph. So I just kind of made it what I have. I figured we can let's cross these out and we can scale it how I wanted. I had to put numbers in there. So if this is pi over 2, then this would be pi over 4, and this would be pi over 8, and this would be 3 pi over 8. And we know we're going to see at each end of this an asymptote and then one in the middle. Okay, likewise, we're going to see, like I said, it's going to be this kind of appearance because of the negative out front. And then, so negative 3, since there's no vertical shift, and positive 3 is what it's coming up to. So we're going to be going up to that, and then we're going to come down to this. I may have used a poor choice of words there. Going up to negative 3, down to 3. And I think that might do it. This is already a long video. I apologize. So yes, nope, there's one more. Sketch the graph of y equals 2 cosecant pi over 2 x plus 1. So we're going to get a vertical shift out of this. And what are we going to have? So our amplitude is going to be 2. So that means we're 2 and negative 2 are going to be some important values, going up to negative 2 down to 2. And then we're going to have, the plus 1. I forgot about the plus 1. Oops. So let's just change that. The plus 1 is going to make that go to 3 and negative 1. Okay, what else do we have? We have b being pi over 2. So the period is going to be 2 pi over 2, which would be 4. So we'd have a period of 4. And so normally we'd have the 0 line here. And we're still going to have on that y-axis. So for an asymptote, and then we do it, 4 is the next one, or not the next one. 4 is the end of the period, so we'd have 1 here in the middle. And if we wanted to go the other direction, we're looking at negative 2 and negative 4. So that tells us our domain right there. The domain is going to be negative infinity to infinity, but x cannot equal negative 4, negative 2, 0, 2, 4, dot, dot, dot. Or you can just say it's not going to equal 2 times k, where k is an integer. Okay, so I think we have all the pieces in here. We have the vertical shift, we have the period. So let's go ahead and graph this. So it's going to come down to this and up. It's going to come up to there and down. Come down to this. It's going to be coming up like that. Down that. And like that. So there's our rough graph of that. Okay, and that'll do it for this video. It's been a long video. Sorry about that.